We're on the last two shapes, pyramids and cones. Okay? So, what is the formula for the surface area of a pyramid? Honestly, I don't remember it. You could remember if you want. It's half times the perimeter of one of the sides times the slant height plus the area of the base. Okay? That's a complicated formula to remember. So, I would just brute force find the area of the base and then add up the area of each of the sides, which usually are triangles, which we know how to find the area of. It's half the base times the height. And in that case, you're going to use the slant height, we say. Okay, so again, you can memorize the formula if you want. I personally don't, and I just brute force calculate it by adding. Okay, if I've mentioned it in previous videos, I don't like memorizing a whole bunch of formulas. Okay, for volume of a pyramid, it's 1/3 area of the base times the vertical height, not the slant height. So for example, this is the vertical height. You would use that to find the volume. 1/3 area of the base times the vertical height. Okay? For a cone, the volume of the cone, exact same formula. 1/3 area of the base times the vertical height. Okay, so 1/3 pi r squared h. Okay, now surface area of a cone, pi r squared, the base, right? Plus pi rl, where L is the slant height. Okay, that one's easy to remember. So you can memorize that. And you should memorize that one because this one is harder to find versus this one is usually triangles. You can find areas of triangles pretty easily. Okay? Now, let's do these problems now. There's 4 of them. Let's see what they ask. The figure above shows a pyramid with regular hexagonal base. By the way, apparently, according to this book, you can assume all pyramids are regular, okay? The length of each side of the hexagonal face is 4 units, and the height of the pyramid is 7 units. What is the volume of the pyramid? Volume is 1/3 area of the base times the height. So, what's the area of the base? That's the challenging part for this problem. Okay, so if you remember, for regular polygons, the area we can find as half the perimeter times the apothem. And the height we know is vertical height 7. Okay, so this is what? 7/6. What's the perimeter of the hexagon? There's 6 sides, each length is 4, so 24. What's the apothem? Now is the question. This, that they sketched here, is a radius of that regular hexagon. The apothem goes to the edge and to the center of that edge. So how do we find the apothem? Well, use the isosceles triangle theorem because here's a triangle, right? It's isosceles because here's a radius. So, what's the central angle in a hexagon? 360 divided by 6 sides, that's 60 degrees. We bisect it, that is 30 degrees here. And this is 60. And we just said the radius is 4. So what's the apothem then? The apothem, well, this is opposite to 60. So let's get this side first. This is a 2, and this is 2√3 over there. So the apothem is 2√3. All right, now let's simplify. That was the hard part for this problem. This is 4/56√3 then. Answer is B. Let me double check. Yes. So clearly you can see that we used previous knowledge once again. Again, in lots of geometry problems, they combine lots of different topics. So here we had to use what we know about regular polygons to help us out here. Water is pouring into a conical, I don't know how to say that word, conical reservoir at a rate of 2.4 meters cubed per minute. If the radius of the base of the conical reservoir is 9 meters and the length of the lateral edge is 15 meters, to the nearest minute, how long will it take to fill up the empty reservoir? So it's filling at 2.4 meters cubed per minute. We probably need to find the volume of this whole cone. And then we just divide it by 2.4 to see how many minutes it takes. Okay, so volume is, what's the volume for a cone? The general formula is, remember, 1/3 area of the base times the height. So 1/3. Area of the base is pi 9, that's r squared, 9 squared, r squared. And then h, do we know what h is? H is the vertical height. It's not the slant height. Be careful. So what is the vertical height? That we can use the Pythagorean theorem. It'll be square root of 15 squared, that's 225, minus 9 squared, that's 81, which is square root of 144, which is 12. So the height is 12. You got to be careful here. Okay? So this is 4 pi times 81. Okay? Which is, what's that? 240? No, 320, 324 pi. Okay? So now 324 pi meters cubed, and then it takes 1 minute every 2.4 meters cubed. So here's where the units help again. Cross those meters cubed out. So we need 324 pi divided by 2.4. That is about 424 minutes. Answer is C. Again, the trick here was this is not the vertical height, so don't use that in the equation for volume. This is the vertical height, which you need to use the Pythagorean theorem to find. Don't get tricked. That's a very common trick. The plane parallel to the base of a cone divides the cone into two pieces and removes the top part. The radius of the cone is 6 inches, the height of the cone is 16 inches, and the distance from the base to the parallel plane is 8 inches. What is the volume of the remaining bottom part in cubic inches? Okay, this is quite simple. Find the volume of the whole cone minus find the volume of this smaller cone. Okay, so how do we get the heights now? Well, actually we have the heights, right? So this should be easy now. Unless I'm missing something. So area of, volume, we're interested in volume, right? Volume, yeah. Volume of the whole cone, so V whole is equal to a third area of the base, that's pi, the base is 6, right? Or the radius of the base is 6, so pi times 6 squared times the height, which is 16. Okay? And then V of the top, volume of the top. Okay, so we do need this length here. So that's what we're missing. It's a third pi times something squared times 8. What's that something? What's this radius over here? How can we get it? Again, this is now using previous knowledge. Similar triangles, how are they similar? This angle's the same. These are both right angles, and this angle's the same. So, yeah, so they're similar triangles. How does that help us out? Well, the ratio of the sides are the same. So if this was 16 and this is 8, then to get from the longer to the shorter, you have it. So to get from the longer to the shorter, you have it as well. So this is 3 inches. So it'll be 3 squared times 18. So times 8. Okay? So the volume that we want is V whole minus V top. Okay? So that is, can we simplify some things first? Actually, let's do it. This is what, 36 divided by 3. Isn't that 12? So 12 pi times 16. And this is 9 divided by 3. That's 3 that's 24 pi, right? So this is 12 pi times 16 minus 24 pi. Okay, I can factor it out. I can factor out 12 pi. 16 minus 2, right? That is 12 pi times 14. Okay. Now, what's 12 times 14? Well, now 12 squared is 144. Okay, so 144. And I need 2 more, right? So plus 24, that's 168. So 168 pi. Answer is D. Okay, again, you need to know previous topics as well. Last one now in this section. If the circumference of the base of This is a different question, not related to that one. If the circumference of the base part of cone is 10 cm and the height of the cone is 8 cm, what is the volume of the cone to the nearest cubic centimeter? So the circumference of the base part of the cone, the base of a cone is like here, it's a circle. So circumference of a circle is 2 pi r, okay? That is 10, okay? And we want volume of the cone, which is 1/3 area of the base pi r squared times the height, h, okay? So we could solve for r directly. Can we do it a little more symbolically to shortcut it maybe? Maybe we don't need to, but okay. Let's just solve for r. R is 10 over 2 pi, which is 5 over pi. So your volume is 1/3 pi times 5 over pi squared times h, which is 8. Okay, so this is 25 times 8 over 3, and there's one pi on the bottom because there's one on top, 2 on the bottom after you square it. So then there's 1 pi left on the bottom. So that is 200 pi over, so 200 over 3 pi. And that is about 21 cubic centimeters. Answer is B. Okay. All right, that's it for this problem set. As always, please like and subscribe if you found this helpful in any way, or if you even just got good practice out of this.